Thank you very much. My name is Richard Amankwah. I'm a professor of minerals engineering at the University of Mines and Technology. I'll be leading the section on mineral processing techniques in ASM. We are looking at safe and environmentally sustainable gold mining for ASM. And as we know, it can be applied in several areas: the prospecting and exploration, the mining, which we have just heard about, in mineral extraction, tailings disposal, and land reclamation. My emphasis will be on the mineral extraction, but then I also talk a little bit about the tailings disposal. For this discussion, we will look at the mineralogy. We will consider size reduction, the size of gold particles relative to the grind size, particle shape and concentration, the sleeve mats, mercury use, and tailings disposal. In Ghana, we have several commodities that can be mined and processed at a small scale level. We have gold, which is the main thing. We have construction material, we have diamonds, we have salt along the coast. It's of interest to note that there are only 2 countries in West Africa where salt can be mined by solar evaporation, and Ghana is one of them. And therefore, activity can also go there. The small-scale mining sector is a very big sector. There were 800 registered participants in 2012, and this figure shot up to 1,500 registered mines in 2017, this year. It is estimated that we have about 1 million people in the small-scale mining sector, and by UN convention, if you have 1 million people in the sector, it means they are taking care of 6 million people. And that means that a quarter of Ghana's population is being taken care of by small-scale mining. That is why when small-scale mining is down, the system begins to squeeze out. And that is what we are feeling at this time. Currently, that is in 2016, we had about 1.15 million ounces produced by small-scale miners, which represented 31% of gold production in Ghana. If you look at the trend, you realize that from the time it was regularized in 1989, with about 2% of production, it has risen gradually, and in 2015, it was about 34%. It dropped to 31% in 2016, not because the production went low, but because another large-scale player, Asanko Mines, came on board, and their production brought the small-scale mining percentage down. Now let us look at some mining methods. My boss has already mentioned some of them, so I'll just pick 1 or 2. We have those who blast. And sometimes when you talk to small-scale miners, the question is, do you have a blasting license? The answer is no, we don't. We just learned it. Some still use chiseling. Others use thermal stress cracking. And some have excavators. We are all aware of some of the challenges in the small-scale mining sector. Thanks to Clemens, I have these pictures. You see that the activity in this pit is very bad. Everybody doing his own thing, mud on the sides, and in case water seeps into this pit, there will be problems. These are some of the challenges that led to the closure or the stoppage of small-scale mining. If you look at these slopes, Ishmael talked about benching. These are benched all right, but they are too steep. And if there's a challenge, everybody in that pit will have a problem. Destruction of forests, we know about it. And these so-called dredges who muddy the waters. We are all aware that you are not supposed to mine 100 meters away from a river. But these people are actually on the river, though nobody has got a legal concession on any river in Ghana. And yesterday when I was flying from Takrady to Accra, I took some pictures at Shama from above, where River Pra joins the ocean. And it's very interesting. Maybe see me and look at some of the pictures. Mineralogy is key when you want to do any mineral extraction. We call it technological mineralogy, which is a bit different from what my boss from Geological Survey presented. we look at the mineralogy as it applies to the metal extraction. And in some of the works that we have done, we try to find out whether gold is really there. If it is, what are the mineral associations? And will the mineral associations allow the gold to be extracted easily, or we have to do some other things? Here, for instance, in the first slide we have, the first picture we have gold with pyrite. If you go to the left-hand side, we have quartz matrix. This is conglomerate material from the Takwa area. Then we have one with arsenopyrite associated with the gold. Sometimes when you have miners mining sulfidic material, they do their analysis and they see gold. But when they pass it over the sluice board, they do not see the gold. Mainly because sometimes they can be very fine or they are still encapsulated in the sulfides. And when it happens like that, they always think that some dwarfs came around to handle the gold. We should be able to try and find scientific solutions to our problems instead of looking for spiritual solutions as a first point. I know we have some pastors around who even in their presentations could talk about hallelujah. But let us find scientific solutions to our problems first before we start praying. I think it will be very useful. As part of the mineralogy, we also have to look at the gold particle size in the ore. What is the gold particle size that we have? Because if we know, then it will help us to know how fine we should grind to liberate the material. Work that we have done in Ghana shows that if you are dealing in an alluvial terrain, as you can see at the top, the gold particles normally would range from about 2.4 mm. The peak is around 2 mm, between 2 mm and 1 mm. And then you have others distributed. Of course, we encounter nuggets that are outside this range. But then if you take samples from all around the country, this would be the average particle size that you get for gold. Below we have those that are milled, sulfides, oxide material, whatever. And you realize that most of the gold particles are between 125 microns and 63 microns. And therefore, when you are buying an equipment in the small scale mining terrain, the question is, what is the size of the gold particle in your ore, and how fine will the machine that you have bought grind to? Now let us look at areas in that direction. Size reduction. Once you mine your material, you have to reduce the size. In doing so, small scale miners use several types of equipment. We have the good old disc mill, or what we refer to as the nika. And our work with products from the nika shows that the average particle size is about 425 microns. 80% passing, not the average, but 80% passing, 425 microns. So having in mind that most of the gold is between 125 microns and 63, it becomes clear that a good percentage of the gold will remain in the tailings after they have milled it. If you look at the typical chamfa, which technically we call the hammer mill, the gold particle size, again as we have seen, against the product particle size of 80% passing 1 millimeter. It means that if you mill with a chamfa and you do not do any secondary milling and you just discard the tailings, you are throwing a lot of the gold away. Not only the fine gold that cannot be recovered by gravity, but even the gravity recoverable gold, you are still throwing a lot away. This should inform how fine small scale miners should grind when they want to talk about size reduction and recovery. Some miners have started using the ball mill. Ball mills can grind to any size that you want. But the challenge in introducing ball mills in small scale mining is that when the ball mill discharges the product, the question is, how do you handle the product? Is it by screening, or is it by mounting a set of cyclones? In the large scale mines, they will go for a set of cyclones. But small scale mining has not developed to the point where they can easily handle a closed circuit system with cyclones and a ball mill. And therefore, this is an issue that we have to look at. Now, if you look at all the equipment that are available, the hammer mill, the disc mill, and the ball mill, and even sometimes the stamp mill for those who use the metal mortar and pestle, the size and the shape of the gold particles that come out are totally different. And some studies that we have conducted shows that when you are using a typical hammer mill, that is the first figure, the particles that come out are globular because the grinding surfaces do not have any direct effect on the gold, and therefore you are able to get them the way they crystallized or precipitated in the natural state. When you go to the second one, that is for the disc mill. Because the disc mill grinds the way the grinding surfaces meet, it actually flattens the gold and then rolls it into a hollow cigar. And therefore, the disc mill sizes and shapes come out as hollow cigars, as you can see. Then the third one is the stamp mill, where they use the mortar and pestle. And because of the metal contact, you get the materials coming out very flattened. And the last one happens to be particles from a ball mill, which are a bit mixed up. If you look at the graph below, this is the drag force against Reynolds number. We are not doing fluid mechanics here, but let me just make a little analysis. You will see that when a sphere is trying to settle, the drag force on it is low. That means that it can settle very fast. But when you look at a plate or a cylinder or a disc, the drag force becomes higher, and therefore its ability to settle becomes lower. This means that when somebody uses a typical disc mill and gets these hollow cylinders, the drag force on it can be so high that sometimes if you don't take care, they will float on the water and be discharged to the tailings impoundment. It is even worse when you have platy particles. That is why sometimes small-scale miners think that we have panned, we have seen gold, but after we have milled the thing and we are running, we cannot see the gold. Maybe some dwarf is around, or maybe there are some ladies who are menstruating around, and they start looking at the ladies with suspicion. Perhaps that may not be the reason, but then the fact that the shapes of the particles you generated cannot settle in a normal steel operation. So we have to look at some of these issues very critically. In one of the tests we did in the field, we tried to consider these shapes, and we tried to build a little flow sheet where when we grind in a hammer mill, we will recover the gold particles that will come out before we go to the disc mill and then recover that one too, instead of going hammer mill followed by disc mill before recovery, because the change in the shape we know has effect on recovery. So we developed this small flow sheet where the ore goes through hammer milling. After that it goes to sluicing, and the tailings from the sluice board goes for disc milling before secondary sluicing. And by doing that, the graph on the side shows that if you go hammer milling and disc milling directly, you get some amount of gold. If you do hammer milling followed by disc, you also get some. But then if you use the flow sheet that we are talking about, you are able to maximize your recovery. This is what we mean when we talk about resource optimization in small-scale mining, by adopting simple flow sheets that have the potential to increase your gold recovery. The miners tell us that it's a bit cumbersome to go by this method. But then if you can spend another hour and get about 10% extra of gold, I believe it is better than being in a hurry and throwing your gold into your sump for a large-scale mine to buy it and then take the gold that it could have been yours. Now let us go to gravity concentration. In the northern region where water is very scarce, they do what we call winnowing. They take the alluvial material, and my boss said he has talked about alluvial material. They take it, they thresh it the same way that you would thresh corn or rice. And once the material becomes fine enough, they take advantage of the fast wind motion to bring about separation. So in this operation, as you can see, the gold will normally fall in the pan and the waste will fall on the sides. So they normally move along with some women. The big guys will process the material that falls in the pan, and the women who are accompanying them will take the material that falls outside and also watch them to see whether they can get some gold. Together they are able to make some good progress. Down south, where we have a lot more water, Some people use trommels in their operations. So you feed the ore into an ore box, and with the use of some hydraulic system, you move the ore through the trommel. Eventually, you have the gold flowing over the sluice board at the side, and any metal of interest can be recovered. In some cases, you also go to a place where you have a lot of sluice boards mounted. The first figure shows some alluvial system where you have several sluices mounted. So as they mine, then the processing takes place. And this picture was taken around Kutukrum, courtesy Clements. We went there together those days when he was in Takwa. The second one was taken around Bogoso at a processing center where small-scale miners bring their ore, they grind it on site, and then they are allowed to wash it. So once you wash the material through the sluice board, the riffles on the mat in the sluice board, they collect a lot of the heavy materials, and with time, you have to stop the operation, wash the liners, and then reline, and then continue your operation. If you have some very rich material, you can collect as much gold as you can see on that mat. Sometimes the question is, how do you select your mat? Do you just go to the market and buy the cheapest mat or the most expensive mat because you have money? Several mats are available on the market. We call some Chinese blanket, we call some AstroTurf, we call some several names. Our research indicates that when you use what they call a typical Chinese blanket with the rubber on the surface, it has the ability to catch only the coarse gold particles, but it cannot catch fine gold particles. That means if you're a small-scale miner and you line your whole sluice board with only the Chinese blanket, you are going to lose all the fine gold particles to the tailings dam. However, if you can couple the Chinese blanket with corduroy material or this kind of towel material, then the Chinese blanket can catch the coarse particles and the corduroy material can catch the finer material, so that you can get all the gold in the spectrum available in the ore. So in our discussions with small-scale miners, we tell them that don't use the Chinese blanket alone, but you can have about 3 different kinds of materials. Perhaps you can start with the Chinese blanket to catch the coarse ones, add corduroy to catch the fine ones, and in between you can use something else like the AstroTurf or like a towel that will allow you to catch all the gold within the system. Once the gold has been picked up, then we go through secondary gravity concentration on the pan. This is material from the sluice board which is now going through secondary concentration. And after going through this process, we have the gold on the pan, which a small-scale miner will call a video. So once you get this video, you can decide to add your lead or mercury, or you can decide to use other methods. Currently, the most common method is to add mercury. So in a typical operation, the miners will add the mercury and physically try to rub the mercury against the gold particles so that it can make contact for amalgamation to take place. So you can see all these 3 people are just rubbing their hands to make sure that the gold makes contact with the mercury. At the end of the day, they pick out the amalgam, squeeze out excess mercury, and then you have the amalgam ball ready for processing. The question we ask ourselves is, should a small-scale miner always rub his hands or his palm against the mercury and the gold to bring about contact? The answer is no. Another very simple method that you can use is that after they have received their video, they get a small bottle. They buy a funnel and a bottle. They discharge the concentrate through the funnel into the bottle. Then they add the mercury to the bottle, cork it up, and just shake it. Shake it for 5 minutes. After that, discharge it back into your gold pan. Amalgamation is complete. No direct contact with the mercury, thereby reducing the mercury poisoning that is going on around us. If you shake it too long, like 15 minutes, 20 minutes, what you will realize is that the mercury will break into very tiny globules, and bringing them together again becomes a problem. Our work shows that 5 minutes is a very ideal time to be able to bring about complete amalgamation and direct contact with gold and then the mercury. On a typical day, you can get small-scale miners who can blow air from their mouth onto the amalgam. The amalgam distillation or heating releases mercury vapor into the environment, and you can see that this guy is actually blowing the air and inhaling the mercury at the same time. Others would also bring it to a fireplace, they stand aside, and then the mercury vaporizes and they get what we call the sponge gold. This sponge gold will be sent to an agent who will now smelt it. So in this environment, more mercury is released and more people are affected by the mercury. The information available to us is that it's not only the miner who uses the mercury who is affected, but all people in the immediate working vicinity also inhale some of the mercury that is released. In Ghana, mercury exposure is a problem because it has been seen to be impacting on the public health of people. In South America, it is worse because they put the mercury on the sluice board directly. But in Ghana, we don't put mercury directly on the sluice board. We apply it only in the secondary concentration operation. But then, the key issues are that mercury is lost in ASM activities. It's lost through spillage, poor amalgam distillation, disposal of amalgamation tails, and further processing of the sponge gold. It is clear that sometimes, if you recover 1 ounce of gold, you lose 1 ounce of mercury. In the best case scenario, 1 ounce of gold goes with half an ounce of mercury. And therefore, if you look at the fact that they are giving us 1.5 million ounces of gold a year, you can do the arithmetic and know the amount of mercury that has been released into the Ghanaian environment. In an attempt to find out whether this was really the case, United Nations released some money for a job to be done in a village called Dumasi around Bogoso. The study involved about 187 people who agreed to use themselves as part of the project, out of which we had 117 males and 70 females. Some were Galamsey people, others were not Galamsey people. But when the test was conducted, it became clear that virtually everybody in the community was affected in one way or the other by the mercury. People who declared health problems, we had about 50% of the women declaring, 40% of the men, but the female Galamsey people, about 60% declared. It became clear that, as has been mentioned already in the literature, mercury was getting more to the women than the men. Normally we know that mercury binds to fatty bodies in the body. And you can agree with me that our ladies have more fat than us, the men. Everything we admire about ladies' morning is about fat. And that is what connects the mercury. Correct me if I'm wrong, please. Right. In terms of the health perception, about 90% complain about metallic taste in the mouth and salivation problems. 65% complained of sleep disorders. 20% complained of tremors. And sometimes, because Galamsey people drink a lot, especially those who work directly in the pits, when they start experiencing these things, they think it's because of the effect of the alcohol. But for some of them, it's because of mercury intoxication and not alcohol. If you look at the statistics, samples that were taken, biological, blood, urine, hair samples, and then nails, fingernails. The World Health Organization standard was 25, but the maximum for blood was 96. For urine, the health standard was 50, the maximum was 252.9. For hair, those of you who have a lot of hair, when your hair is growing, it picks the amount of mercury in your blood and registers it there. So if I cut a sample of your hair and I digest it, I'll be able to know the amount of mercury that was in your bloodstream at the time when the hair was forming. The health standard was 10, and some people registered 44.6. In the fingernails, the health standard was 10, some people registered 55.7. And this showed clearly that mercury was having an impact on the public health of the people in the community. So, as part of the control measures, one was to reduce mercury use in small-scale mining, and the other one was to reduce mercury loss. So, for reduction in mercury use, the key issue was to find alternative methods, and for reduction, to find ways and means of reducing the mercury that was released into the environment, especially in these days when Ghana has already ratified the Minamata Convention on Mercury. It becomes more important for us to find better ways. At the time that this work was done, we had this steel retort on the market, and small-scale miners, some of them were using the steel retort. At a point in time, they stopped using it. The reason being that they did not see what actually goes on inside that metallic unit. And since they believe that people with spiritual powers can change many things, the idea was that if maybe I'm working with you and you're at a higher spiritual level than me, at the time when we cannot see what was inside, you can actually pull out my gold and put it in yours. And to add to the problem, sometimes the gold came out a bit colored, and therefore they stood on the color issue and the spiritual issues and stopped using the steel retort. UNIDO introduced this Tembex retort on the market. This was designed, I think, somewhere in Germany. So you put the gold, in that small section, that small bulb, and you bring the bulb to a fire source, and then you distill off your mercury. Over time, it became clear that this unit was not very robust enough for the small-scale mining terrain. And to add to that, there were no spares. And therefore, whenever your glass cracks, there was no way you could get replacement. So with time, they ended up as museum pieces in many of the offices of the people who bought them. Now, based on the challenges associated with this glass and then the steel, at UMAT, we decided to see whether we could add one more retort to the market. And we developed what we call the lantern retort. The lantern retort combines the fast heating kinetics of steel and the see-through effect of glass, so that the heating can be done faster, but then whilst it is going on, you can also still see your gold and be sure that nobody is taking it out of the retort. Since I designed it, I've given out 30 pieces for people to try it on the field and give me feedback to see whether it is working for them. And some people who have come back with issues are saying that when they have very large amalgams, they are not able to use the method because the bulb is too small. But normally I say, if you have a very large piece of gold like that, don't use this. Use another method we call direct smelting. At the moment, I have several requests for this lantern retort from some players in Burkina Faso, Nigeria. But the artisans who manufacture these for me, you give them one, and for 30 days they are still telling you stories why they have not been able to do it. I'm trying to link up with Crystal Asaf and give them the permission to manufacture as many as possible. Now that they have been able to manufacture cars, I believe they can manufacture this lantern retort very easily, so that they manufacture it and then make it available to as many as would want to use it. Another way by which we introduced a technique to stop the use of mercury was what we refer to as the direct smelting method. This project was done under the EU-sponsored Ghana Mercury Abatement Project. Add sands, the composition, and try to put together some chemicals, borax and soda ash, both of which are non-toxic. Soda ash is in bread, we eat it every day, and which we could mix to make sure that the method could be sustained. So we came up with this idea that when you have 1 cup of black sands, add 2 cups of borax, 2 cups of soda ash, and then smelt it. The weights are there, but small-scale miners don't take electronic balances to the bush. But then you can easily get a small tomato puree can that we have shown there. So 1 tomato puree can of black sands will normally go with 2 tomato puree cans of borax and 2 tomato puree cans of soda ash. If you get these off, then you can mix it and then pour it into a crucible and then eventually smelt it. In this project, we came up with 2 types of furnaces. One was a charcoal fire furnace, which allows the material to be smelted directly because we could measure about 1,500 degrees from these charcoal fired furnaces. But then the one that became more popular was the gas fired furnace, which the small scale miners called sikabuchia. So if you see a sikabuchia in action, you have this unit there which is connected to the gas. Once you put your prepared material in, within 20 minutes it would have melted and ready for pouring. You pick the crucible out with your tongs, you pour it out, you allow the melt to harden, and you see the gold at the bottom. Once you crack up the slag, the gold is ready to be sold directly. This direct smelting method came up, and initially it was very successful. On the field trials, we had some challenges. In the lab, we were using quite ideal conditions, and therefore everything was very excellent. When we went to the field, some of our tests failed. So we came back to the drawing board to see what exactly was going on. The challenges we observed were due to 2 main things. One of them had to do with sulfides in the concentrate. If, let's say, you are working in a sulfidic environment, you will have a lot of sulfides appearing in the concentrate. And those of us who know basic smelting knows that when you smelt sulfides, you don't get slag, you get matte. And it was the matte that was actually messing up the whole operation. So the solution we came up with this is that when you have sulfides in your concentrate, whilst the sikabuchia is warming up for action, get your concentrate on a tray and put it on top of the sikabuchia where the block is. Whilst it is heating, the sulfides will get oxidized from pyrite to hematite. And once you move from pyrite to hematite, hematite is an oxide and it can be slagged easily. And therefore, when you smelt it, you will not have the problem of the use of sulfur in the concentrate. Another problem we encountered on the field was the fact that when they grind, sometimes part of the grinding surfaces break off into the concentrate. And when you concentrate by gravity, all the steel will remain in the concentrate. So the idea was to find a magnet that was good enough to take those metal pieces out of the concentrate without taking the gold away. We tried several magnets of several magnetic strengths, but the one that worked for us was this magnetic alphabet set that we normally stick to fridges. You know, these flowers and alphabets we stick to fridges. When you pull all of them out, they have a small magnet in it. If you take out those magnets and put it in a small rubber container, these INSU containers, they become very good magnetic separators for this thing. So small scale miners who want to use this, just buy yourself a magnetic alphabet set, pull out the magnets. The Tesla value there is about 0.0025. And that is good enough to pick out the magnetic pieces without taking out the gold particles associated with the black sands. With these two, we have managed to solve the problem that we met on the field. And if we get a chance to go out there again, I believe that the process will be very successful. At the moment, the Commission on Small Scale Mining has contacted us again, and hopefully we will go out on the field and train some people to use this method again. The advantages are that it is fast, transparent, and recovers the gold in one step. You know, in the typical system that we have, there's a value chain. We have the bush buyer who will sell to an agent, who will sell to a dealer, who will sell to an exporter. But then, this system allows the small-scale miner in the pit himself to get his gold directly without using an agent. I'll end on this tailings management issue. Nowadays, if you visit any small-scale mining site, the tailings or the waste material are scattered all around. The waste rock could be stockpiled, some discharged directly into streams. Mercury polluted effluents are discharged here and there. Some even sell their tailings to large-scale mines. But the question is there any good way by which you can dispose these tailings without affecting the river bodies around us? And the answer is yes. It is important that we make sure that we don't have high suspended solids in our rivers. It is important that small-scale miners increase their housekeeping records, and the disturbed landscapes and abandoned pits should be taken care of. The issue of abandoned pits came to me very strongly one day when I was working at Nkutimsu area, I am free. One lady who had just given birth to twins was walking around in the morning. Unfortunately, she didn't know that there was a pit in front of her house. There was a pit and it had overgrown and it was filled with water. This lady went out and just fell into the pit. Nobody got to know it. So the children were crying, everybody was looking for the woman before we realized she was dead in the pit. Very unfortunate. Small-scale miners who are here, please let's take note of that. I think it's about time we move from waste disposal to waste management. And therefore the questions that we ask ourselves is, how do we handle the big boulders that are generated? What about the barren pebbles, the trommel discharge? What about those who wash directly into river bodies? What are the best practices in handling tailings? We are proposing this water recycling 3-stage water purification system, where we say that if you have a sluice board or a trommel on your own concession, dig 3 big ponds. The sluice board should be placed at the mouth of one of the ponds, where you wash your material directly into that pond. The solids will settle there and the water will overflow into the second pond. Then it will move from the second pond to the third pond. If the water is very muddy in the second pond, you can even add some alum, so that by the time it moves to the third pond, it will be ready for reuse. So that the miner will use the water in the third pond for washing and not go to the stream close by. If you do this, it means that you will not have any direct contact with the water body in your area. But all the water that you use will be within your own system that you are recirculating. In case you have any problem and you need more water, the only thing you do is to pump water from the stream into your third pond, and then you continue using it, and then you don't have any problem with the rivers around. If we are able to do this, I think rivers like Ofin, Pura, Bia, and Tano will be clean in the shortest possible time. Moving forward, we think that education is very important. General education and specific education. Specific areas that require education has to do with blasting. Many small-scale miners blast, but nobody has got a blasting license. We have linked that with big men like Godwin, and we are saying that every district should select about 10 people who are interested in blasting. We bring them to UMAT, we teach them about blasting, we take them to the inspectorate division, and they certify them. And their names are published in the districts as people who are available and ready to blast. If you want to blast, call them, they blast for you, pay them a fee, so that there will be sanity regarding the blasting area. In recovery optimization, we've had several discussions with them, and it's still ongoing. Mercury usage, yes, and tailings management. The truth of the matter is that you cannot enforce a law when about 80% of the people are disobeying it. And therefore, once we keep educating and educating, a time will come when more people will be doing the right thing than the wrong thing. And then sanctions for those who are doing the wrong thing can come in. If you start applying enforcement now, all the prisons will be filled with people who are disobeying it, and we cannot even contain it. This, I believe, is the way to go. And I see the leaders of the small-scale mining association as very proactive people. They are working very wonderfully. If you go to their own personal sites, they are using the right technical methods. And I believe as we interact with both the legal and the illegal miners, the sanity in the system will improve and everybody will be happy. So that we can all encourage the system that takes care of about 25% of Ghana's population. Thank you very much.